All right, looks like this is fine. I'm just checking out my mic. Yeah, seems much better. Yeah, Kamal, I'm going to do that today. I'm going to talk about stream and explain about all the different types of streams that are available uh, with Dart, and we'll discuss about it for sure. Give it another minute for people to join, and pretty much after that, you can get started. Mm-hmm. All right, I'm going to get started with this right now. So for this session, we're going to be primarily looking into understanding about streams and futures. I'm going to be going around with what we did in yesterday's session as well, because that's where things get started. Things should get started. So if anybody's there who missed the yesterday session, you needn't worry about it, because I'm going to be giving it as brief as possible. But if you want like a detailed explanation of few topics, you can just look into yesterday's session. So for this one, we're going to be looking into, like I said, asynchronous programming. Asynchronous programming is different in each programming language. Python has it in a different way. If you ask like Java probably has it in a different way. Hi Kamal. And bunch of different things, bunch of different languages have it in a different fashion. So what we're going to be doing for this one is to understand how Dart processes asynchronous programming, like what are the different things that are available with Dart, and how you can actually start writing your code in asynchronous fashion. And asynchronous fashion is nothing like very complex. Yesterday we discussed how and what are the different importance, and like what are the different things that are possible with an asynchronous when you write code in asynchronous fashion. So let me share my screen. All right, everything looks fine. So yeah, so what we did yesterday was to understand how this whole topic of asynchronicity worked, and I kind of like I still have the diagram from here. We talked about everything about here, and this is what we did yesterday. So I'll just will give you like a very brief understanding of what we did yesterday and what are the different topics that we covered, and post that we'll get started with understanding about futures and streams, and pretty much dive deep as much as possible. So we're going to be covering all of that in today's session. uh Yeah, come to this, but all right. So before we begin, that's what I wanted to come to. So before we begin, we need to understand what exactly does an asynchronous programming really mean. And asynchronous programming is not too complex. So asynchronous programming just says that do not think of you writing your code in a linear fashion. So when it's a linear fashion, that means that A gets executed, then goes to B, and then goes to C, and then goes to D, and this is kind of like a linear programming fashion that we have always been seeing so far. And what happens is that what if I want to just get past all of these things, or what if I want to write or run everything in parallel fashion, right? I want to execute all of this code in a parallel fashion instead of like a linear fashion. Instead of going horizontal, I want to go vertical. This is what was thought behind all of these programming languages. This is primarily catering because of the advancements in the CPU. And yesterday I forgot to talk about it, because if there is no CPU power, for example, you have i9 processors now, and you have bunch of complex processors that are running. AMD is out with very top-notch processor. Hi Sumit, how's it going? Good evening as well. So all of these are possible. With CPUs becoming more and more powerful, our code should also run faster. So this was the whole idea behind Dart, and this compiler was built probably 10 years ago, and this compiler has still been there, and this is what Dart is trying to do. And all of these programming languages that you see right now, let's say that you want to drive a Tesla car, and a Tesla car is able to compute a lot of different things in real time, and it might not be possible if you wrote everything in a synchronous fashion, right? Let's say you have a car, your Tesla is running, it's trying to do the autopilot. My volume is not fine. Like, I don't understand why my volume is not fine. Hmm. Let me check here. My volume seems fine. What else can we do to make it louder? Just tell me now if it's fine. I'm just very close to the mic, but even if it's not fine after this, I need to get a new jack. Okay, I'm guessing this is fine now. I'm talking as loud as possible. I can't shout more than this as well. So hopefully this is fine. And if it's not, if it's very less for you, I'd recommend you to like put on an earphone or something like that, so it's much more easier. All right, so let's continue on. You're talking about the Tesla car. The Tesla car is running in a street, and we have like it needs to compute things in much better fashion. It cannot like do things in a synchronous fashion. So there's a Tesla car running here, and there is another car coming on this fashion, and you are doing like a right hander. So this is going here, and there is another car trying to take a left on here. And if you write your code in a synchronous fashion, the first thing it will do is to check if there is any object in front of it, and it will check it needs to slow down the car, and all of these things needs to be done in a synchronous fashion. If it is happening A after B after C after D, this will probably not even be possible. There is nothing that is possible. It needs to compute probably millions and millions of lines of code. It needs to compute millions of different things that it is trying to perceive from the outside world, and still take action or take a decision in probably less than 1 second. Not even less than 1 second, probably less than 500 milliseconds. So if you want this kind of speed, you need to obviously have a better compiler, and this better compiler options came with the help of Dart. And we never know what Tesla is doing it, like how much of a different programming language, or what if Tesla is already having its own compiler. We never know about it. But what happens is that in the case of a Dart, I'm just giving it as an example, the car is able to do it, and we need to still be able to do it. So they wanted to have a programming language that would support this kind of an asynchronicity, without having to depend on an external framework or depend on an external technique to make things asynchronous. So all of these programming languages that you see, like Java, C Sharp, and things like that, they still write things on a synchronous fashion only. But with the help of the recent changes that they have tried to make, there's asynchronicity still possible with these programming languages, but with the help of some kind of an additional external library, and that is what is bringing asynchronicity to it. So but the Dart, it's already inbuilt inside the compiler, and that's what we talked about yesterday as well. So this is going to be the whole idea behind asynchronicity, and we're going to be looking into how it is possible, how it is made possible. The first thing that we looked at yesterday was the concept of futures, and that was the only thing that we talked about. I didn't want to talk about streams yesterday because it's kind of like a complex topic again, which I wanted to cover it in a separate video. The future is just a simple way of saying that I have a return value that I'm going to return to you probably in the future, say 20 seconds later in the future. So this program here that is running, the code is executed, and the compiler is now coming to this part, which is this code B, and this code B is now marked as async, which means that this will run in parallel. So just don't worry about me, just keep on going. So as soon as the compiler sees that a code B or a function B is running in asynchronous fashion, it will just mark it as running in asynchronous fashion. Let's jump to the next code line. So module C. This is how the asynchronous fashion works, and probably after 20 seconds that the when you mark something in future, it means that you need to expect a response, and if the response might come, if the response might not come, you never know, but you're saying that there's going to be some kind of a response in the future, and we're just trusting that there's going to be a response in the future, and we're just moving along. And this might take 20 seconds to execute, 30 seconds to execute, and finally it'll come out with an answer, and that is simply going to be happening in completely in asynchronous fashion. You never know what is the next stage for that. A first gets completed, B gets started, but is supposed to be running in asynchronous fashion, but so we skip it, we go to C, and C gets executed, and B might get executed, might not get executed, you never know. That's also like another pitfall of futures. So this is what we looked into, and we also wrote some code around it, and we understood like this is the entirety of futures. So I'll just mark one important line, or mark one important step here. And when you think about futures, think of it as just one return type. So this is something that I'm going to talk in depth again here for this one, but just think about futures as a finite value that is going to be coming in the future for sure. Might finite value in the future, or might not give any value at all. So the finite value in SA, it could be a one simple string, it could be an integer, it could be a double, which is a float value, it could be a boolean data, any kind of data that is sticking to the base data structures or base data types. and it will probably return either a string, an integer, a double, or boolean. It could be list of strings, it could be list of integers, anything of that sort. Any combination is accepted, but for now it should return any one of these major data types, and that is pretty much what the future is going to say. So this is what we looked into yesterday. We wrote some code as well on our dart pad, and we tried to do some techniques around it, and that's what we primarily did. So for today's session, I'm going to just be continuing along in the same way, and we're just going to be looking into what exactly is the futures going to do. Yeah, this is where I wanted to start with. So future object represents a value that may potentially happen, and the next step is very important, and we're going to be talking about that as well. An object can attach receivers to read the response. So we'll see what these receivers are, and you just need to be aware of the different function terminologies, and these terminologies are important because if you want to really understand it in depth, try to like try to compare it as much as possible to what you're doing in a real life fashion. And most of the programming languages work in that way, because if you want to they just try to keep it as close to possible as what is happening in real life, so that all these terminologies are easy to remember, right? So when I say receivers, right, just stick to this word right here. I'm just going to be talking about it, but for now, this an object can attach receivers to read the response. So this is what we're going to be finding out right now, what exactly are receivers and how you can attach them to a future object and read the response from a future method. So let's go to the dart pad now and write a simple, probably a simple future method. So obviously you need a main, so probably this is what you guys are looking into. Okay, main function is there. Obviously, as you all do, this is the start. Just say this is the start so that we know how it is getting executed. Followed by that, this is the end, and we are pretty much done. So in yesterday's session, I showed you guys the syntax for creating a future method. So I'm just going to quickly write it here. The syntax is very simple. Create a method. I just say future function, and just mark it as async. When you mark the function as async, so async is probably after you are done implementing your parameters. So after this bracket, you need to just mark async and open up and close your flower brackets. So this, when you mark something as async, you also need to mark the return type as well for this. So just say future of. When you open your future of in a this fashion, which means this is actually the angular brackets, you need to now tell what is the data type that you're going to return as. I just told you that it needs to return of these four basic data types, or it could be a combination of list, set, and things like that. But for now, it could be a basic data type. So I'll just say for here, it's going to return a future string. So it's going to return something in the future, and it could be a string. And as soon as you return something in the future, it just throws an error saying that body might completely execute and return null, which is not something that you need to respect. So you just need to return something in the future. So we just do another thing here. We will just say await, and we'll just wait for 5 seconds, and we're just going to say like future dot delayed, and delayed is probably what we're going to be seeing yesterday as well. So future dot delayed const duration, seconds is going to be 5 seconds, and we need to definitely give it a functional callback. So empty function callback is what we will be saying. So print this is inside the future. All right, and we definitely need to return something here. So we'll just say return a string. So this is completed. So that's pretty much it. That's what is expecting. It's returning, is expecting a return type of string, and when you just return it as a string, it just accepts it as it's going to be in the future. You don't necessarily have to attach it to any other object. So that's pretty much it. So you have a 5-second wait here, and then it is returning this is completed as a string. So when you try to execute it, or when you try to call this method here, like if you really want to find out what is the data that is getting returned, right, that is where the concept of receivers come into picture. And one of the most important receiver is the then callback, which is what is going to be, which is what is given right here. Yeah, so setting callbacks for future is pretty simple, so it's not very complex. So you understood the concept of futures. Callback, so callbacks I'm trying to explain to you. So this is what is going to happen. The future object is present, that's present right here. um, there's a function right present right here, right? So there's a function present right here, and this function a is trying to return something in the future. Now, how does our program know that this is going to return something? Now, if you do it as a normal function call, like something like this function, just call the function a like this, it will still call this function, but it will never wait for the future's response, because we know that it's going to happen in the future. We should normally call it, just do a normal call. The function call will not wait. It will just get executed, take a normal function and just move on. And but we don't want that, right? We want to wait for the future to get completed, get the response, and then also print it. And when you try to do that, you use something called as a callback. Now callbacks are a special type of function receivers, and just call it as receivers. And these receivers are what is responsible for handling a future's response. So let's take it in the simplest fashion. There's a person a here, let's say a, and he wants to call person b. And this is how futures also work. The person's trying to ring this guy's number. It's just ringing and ringing. It's waiting, taking probably 1 2 3 4 5 seconds for the person b to pick. And when the person b picks up the call, that's when the a and b gets connected, right? That's when you talk and do all the stuff, all of those things. So that time difference when it takes for the person a to call person b, and then it is taking that 5-second timeline. And in this 5-second timeline, the call is continuously ringing. You hear the ringing tone until the person b receives the call. You can never talk anything. So that's the same application that the future is also trying to do. And this 5-second wait time that you're waiting for, this line should still be open. If the line is still not open for 5 seconds, if the ringing tone is not coming, that means that the call is ended, right? That, like, you never know, like, this call is disconnected. So this 5-second ringing tone that you're hearing is similar to a callback. This callback is responsible for that futures to get, or the a and b to get connected. So a is the function that is going to be called, and b is the function that is going to be calling that place. So there's a print statement that we have right here, and then we have two print statements. I want to just invoke this function, which is the future function, right here like this. I can still do this. This is still accepted. But if you do this, this means that it's just going to call this function and move on to the next line. But what I want is for wait for the person to finish this function to get finished, and then I want to get connected. So that's when you talk about callbacks. So these are basically the simplest way to explain callbacks. Callbacks are just to fire up when a function is getting completed. It will call back to this place where it was invoked, and it will do all of those things that you would need to know. So hopefully this is clear. This is what receivers are for. And the word receiver is very, very important, because when you say receivers, you just talk about a finite number of data only. The finite number of data is for like one string response, one integer response, one probably boolean response, just one response alone. So this finite number of responses are handled by receivers, and the receivers are in turn attached to a future. You only attach a receiver, which is the then callback. This is the callback that you are attaching to the future. If you run without it, you will get nothing. It will still work, but you will not get this is completed print. So let's try to print this. So you print it here, like you want to try and see to print it, right? So you'll just print it, because it is returning something. Run it here, nothing gets executed. You just get, it'll execute, it will definitely execute, but it'll just say instance of a future string. It will not return the value that we need, because it is taking 5 seconds. You see here, this is the future getting executed after 5 seconds. So technically we want the value to come to us, but after 5 seconds. But what we're doing is we are not attaching any kind of a callback to it. We are not attaching any kind of receiver to it. We're just making the call and just putting the phone down. That's not how you do it, right? You need to wait for the other person to pick up the call. And that's what is exactly happening. If you don't have a mechanism to pick up the call, and you want to pick up the call, that's when you attach your then callback to the future function. This then callback is providing us a lot of options to read the value, and it's pretty simple as well. So I'll show you guys how to attach a then callback. So take any future function. What am I doing? All right, I take any future function. It needs to return only a future object. Just make sure that it is returning a future object. And if there is a future object present, just say future function, and just attach the then callback to this. So as soon as you say then, it will understand that you need to have some value present inside. So it's similar to this now, and I'm just going to re-invoke the concept of function shorthand, where you can actually create functions within a receiver callback. So just say something like this: open and close brackets, and pass a value. So whatever this future function is trying to return will now get executed within this function value, this variable value. So what you can do is just say oh, and just use the function shorthand notation to print this is the value and attach the value to it. So we are pretty much done here. So what we've done is execute the function, future function, and it just call that and come to the next line, which is that this is the end. It will print that, and what will happen this time is it will wait for 5 seconds and it will print this first, and then it will come and print this second. So that's what you're going to be expecting to see. So just say this is the value, this is completed, right? So let's see how this is turning out to be for yours. So this is the start, this is the end getting completed, and after that this is inside the future is first getting executed. So it's waiting for 5 seconds to wait for this delay to get executed. After that, it is successfully able to come back to the same place and then execute whatever was the return types. So this is the call back. So it's calling back and waiting to the place where it was invoked, and then printing the value to it. So this is going to be the simplest receiver that you will see, and you can also do a few other things as well to this, which I'm going to tell now. Any questions so far here, guys? I do see a lot of people now joining the stream. If there's any question, just let me know. Then value can be empty. So asking about this is the function shorthand notation. This is basically a function callback without a name. So this is basically saying whatever is inside the then, if you want to print the value, you need to pass it as a variable here. You can pass any variable here. If you just leave it as such, nothing will get executed, because I mean this then will still get fired. It will just say that there is an positional argument definitely needed. So you need to pass a function to read the response from this future function. The future function might never return anything. It might return null, it might return some data. You still need to pass a empty function inside it to handle this kind of data. If you don't pass an empty function, then it'll not accept it then. So then should always have like an shorthand, the function shorthand, so that it is able to print the value that is coming from future. Let's say there is returning something else, there is returning null, and this will not first will get accepted. It will just say that null is not accepted because you need to have a return type of string. So if you say that this is let's say that you want to return a null here, yeah, and you just return some empty, just return empty here, and it will just throw an error right here saying that a void expression can't be used. So the compiler is smarter enough to know, yes, it's just a copy from the function of the future. No, so you need to think of it this way. So I'll just explain how this then callback works. So just go back to where we were. Yeah, this is pretty much what we are doing, right? This is how the then callbacks is getting fired. So the then callback, as soon as you attach a receiver to a future object, the future object is here, right? And this is the function that you have written, which is future function, and it is returning something in future. Okay, we'll have that. And you have the first print statement. Print statement is present here, and the second print statement present here, and you're executing or calling this right here. So just say future function of, and then you're attaching the then callback here. So when you say then callback, you need to pass a function to receive the future's response. If the future's response is going to be null, it's not going to return anything, then you don't necessarily need to attach a then callback. If you are expecting some data, that means that you need to handle the data, right? You need to get a copy of the data. So what you're doing is that time you're attaching the then callback, which is basically when you say dot then, it's pretty much like saying invoking a function. So just invoking this function, and in the then you are using the function shorthand. So function shorthand is something like this, right? you just need to do something like this. This is the function shorthand, and without having to create a function with a name, you can just say an empty open and close brackets using the equal to greater than symbol, just like an arrow, and do something like this here. It'll just do like one print statement. You can't do a bunch of things, just do one simple line. So you need to definitely pass this function callback. So how this then will do is it will see the future object here, and this function will just be acting like a separate object that will be here. It will just be like this, and it will have like a variable value. And as soon as the future is finishing after 5 seconds, it will find this function and it will attach the response from here, which is the return value from here, to this value, which is a variable that you're passing. It could be value, it could be data, some value or some variable name. So as soon as you attach this return after 5 seconds, the return value get passed inside this function's data variable that you have right here, and then it try to execute it as a normal function. So this is the property of then. So whatever function you are trying to do inside this, it will just wait for that as a block, and as soon as the 5 seconds gets completed, it'll return value alone will get passed inside this. So that's pretty much how the then is trying to do, the compiler is trying to do in the background. So that's how you attach a then receiver to this. And let's say that your function is throwing an error. Error functions are very, very important. You need to also handle error applications as well, where you're thinking that the value is going to be successful, but there is some error that's getting thrown. You need to handle that as well, and there is another callback for that as well, which is called as the catch error function. The catch error is similar to then, which will then is for handling any return type. The catch error is for handling any type of exceptions. So that's how you differentiate them. The compiler is smart enough to know that there is a return type coming here, like return data coming through this channel, or there is actually an error that is being thrown by this future function. So in that fashion, you will also have the catch error function or the catch error receiver. So similar to this, let's try to see how it works in a code itself. So this is pretty much a simple function for now. It's just returning some data. But what I'm going to do now is, instead of just returning some data here, I'm going to try to attach few things along with it. So I'm just going to say just return is fine, but even before return, I want to just throw a error. So I'll just throw an exception. I'll just say the exception for some data right here. That this is a sample exception. So when you say exceptions, that means that some kind of an error is being thrown. So just remove let the return be there. If you don't have the return, then this future function will not, the compiler will not allow it. So even after the 5 seconds, after this future is the delay is completed, you'll just throw an exception right now. So let's try to run this code right here. If you see the code right here, try to wait for 5 seconds. See, it's throwing this error right here. It's saying uncaught error exception. This is a sample exception, and it will just kill the program right there. You have worked so hard, and it will just kill the program right there. Can you use dollar in place of plus, just interpolation? You can do that. Yeah, you already asked this question, but I'm from the Python world, so I usually use the dollars for we usually use the open close brackets for the f string, which is a format string, and I'm just used to this, using this plus a lot. So you can still use the dollar interpolation for sure. Anyway, so yeah, I'm going to talk about throwing exceptions right here. So it's throwing this exception right here, and it's just killing the whole program, which we don't want. If there is an exception that is thrown, I want to handle this exception. I want to say, don't stop this entire execution right here. Instead, do something else. Just print that there is an exception. So we're just going to ignore that exception and just move on. This is what I want to do. So in order to do that, you will use the next callback, which is called as the dot catch error callback. So just say dot. You can just continue or attach as many receivers as you want to by just putting this dot attached to it. So you can, this is first receiver that you're trying to attach. After that, what you're trying to do is just say dot catch error, and you'll use the same thing that you did right here. Just use an empty function, open and close empty function, error message, and you just now handle this error message. You will say that this error is handled. That's what you will say, and pretty much that's it. So just say error, and we'll just see what error it is getting printed. So pretty much that is done. So you just close with the semicolon. So this is how you attach receivers to a future object. The future function is right here. You can attach the first receiver, which is the then receiver, which will only get executed when there is a return data coming in. The catch error receiver will get executed when there is an exception thrown from the function. So these two things are done. We'll see how this is getting handled right here. Just see how this is getting handled. Same thing will happen. This is the start, this is the end, and this is inside the future will get printed. Exception is not a subtype of string. Oh, okay. This is what happens when you don't do a toString. Just do a toString, this will fine. Okay, awesome, right? So it's saying this error is now handled. This is a sample exception. Though this error is getting handled, it's not killing the program. It will just move on to the next line as usual. So it will just continue on. Let's say you have 10 different 20 more code lines to get executed. It will just carry on. So this is how you attach receivers to a future callback, future functions, and future data. Whatever is written in the future can be handled with just these two important receivers as well. There are few more receivers that you can just check out the documents for. There are receivers probably to let me check quickly. You get a bunch of different things as well associated with it, but these are the two important ones where you use the then receiver for just the return data type and the catch error for handling the exception. Now, so Kamal asked, when do you use an exception and when do you use a return type? So this is very important. Now let's say that you are writing a huge code and this 5-second delay is taking so much time that you're trying to receive or trying to get some answers from a server endpoint that is taking so much time. Say it's taking more than 2 seconds, it's taking more than 10 seconds. You as a developer, you should be aware of what is happening, and since a future can never return some data, that means that the future might not come out at all and it might get your whole program stuck at some point. And not to avoid that, you should always be aware of what time it is taking. So let's say that instead of 5 seconds, it's taking 50 seconds, which you cannot allow. Your program cannot wait for 50 seconds. And it's, let's say that the entire code is now stuck. There is no way that is a response going to come in the next 5 seconds. So what you will do at that point is that instead of just returning some data, you will just throw the exception. The exception is the only way to exit out of a future function without having a proper return type. So if the return type is not going to come at all, you can only throw an exception to stop this function from getting executed, or else it will keep on waiting. That there is no way it will finish this method. So just throw an exception if there is a response, and if there is no response, if there is a response, then just return that data. This is what we very frequently see in Flutter. When you created the full Flutter application, we used to see a lot of this happening, especially with the scaffold and the future builder method, which is the future builder widget. That will keep on wait for understanding about this. I know, come on, just stay a little bit calm about this. You understand that you want to learn to you want to understand about stream, but I just want to cover as much as possible. So I know when to start stream. So anyway, so this is what is going to happen. This is pretty much how you are understanding about the entirety of futures. That's true. I understand, Sumit, that you understand that the plus operator is it does get printed, and the whole idea behind dollar is actually for the formatting. The compiler is much more understanding of the formatting of the dollar. That's inbuilt in Dart, but it's still, if you want to use plus also you can use plus, but most probably it's good to use the dollar only. I'm not going to say anything about that. Well, I just move on to the streams. Stream is what we're going to be learning now, and this is actually one of the interesting topics to cover, but at the same time this is also something that you need to decide if you want to know about it or not. So what exactly are streams, and what exactly do these things necessarily do? So I just written it as streams represent a set of information that may flow continuously, and when I say continuously, there is no concept of finite attached to this anymore. There's you should always think about it as an infinite number of information that is just going to flow continuously. There's no discrete data coming in. There's always like a continuous data coming in, and that's what our streams are used for. And streams in particular are primarily used in particular for broadcasting purposes. Let's say this whole YouTube is streaming right now. This whole YouTube streams is happening, as the name suggests, it's a stream. There is no like fixed pictures that you are seeing. You are seeing a continuous video, And when you say continuous video, there's probably 30 frames per second, or 33 frames per second, or 60 frames per second, and that is what you are trying to see. And when you want to see these many number of frames per second continuously being streamed, then you have the concept of streams in programming. So you want to, instead of just showing one data type, one return type, one value, you're trying to return something in a continuous fashion. So that continuous fashion is what streams are used for. And instead of just receiving a stream anymore, you won't receive a stream, you'll only listen to it. And that's pretty much what this whole thing is going to be about. So I'm just going to be explaining about it with another example in about a minute time. So let's do it. All right, so let's get moving on. So this concept of streams, right? Let me give you a better example, so if you guys might find it easier to understand. So the streams, there's a point A which is right here, and think of this as the YouTube stream itself. So YouTube, I am the person here trying to stream. I'm in location A, and there's another server at location B, and it is the YouTube's ingest server, where ingest servers are just for getting all these stream packets, which is video packets, and then it is trying to communicate with another location, which is the C, which is going to be what you guys are seeing. So it's the youtube.com. That's what you guys are seeing, right? So what happens is that from the person A, there's a continuous stream of information. You don't put an arrow anymore. You put a continuous stream of information in this kind of a pipe, right? This continuous flow of information right here. Think of it as a water pipe. The water does not, you cannot count water, right? How do you count water? You count it in the form of liters. So there's a bunch of different water, or in this example a video stream, that's getting transmitted from A to B, and the B here is just listening to the data. It's not receiving anything, it is only listening to this data. And from A to B, there's, let's say there's about 2-second delay, 2-second delay for A to reach B, because it's a huge pipe, starts from A and goes to B, and it's taking a 2-second delay to reach B, and this B is just listening continuously. And once the B is continuously finishing listening, yes, so I'll talk about it again. For Sumit's answer, Sumit's question, I'll give you an answer, but for the B, which is going to be continuously listening, right? It'll just listen to the stream of information, and it'll do some processing here, and it'll create another pipeline from B to C and send it out as a video packet. So this video packet is what you're finally seeing as the YouTube video. So this is the continuous stream of information, and this is why streams were required in the first place. If you were to send every single frame, let's say that you want to stream at 30 frames per second, right? 30 frames per second. And if you want to stream 30 frames per second, you can no longer send it as one frame first, second frame first, third frame first. You should also account for the 2-second delay that is going to be there. And in order to stop this 2-second delay, you're going to be sending it in the form of a stream, where every single packet information is just going to get clubbed together, and it's just going to go together as a stream of information. I just now told what a listener is. So the listener is to just for listening purpose. You no longer receive anything here. You're just listening for some information. This listening information is when you say, I'm talking to you. You are not hearing, you are just basically hearing a sound wave going inside you, right? You're not receiving data anymore. You're just listening to things. And that is the concept behind streams. So for the future, which is a finite information, you receive things. But for a stream, which is a continuous information, you listen to it. You are no longer like receiving any information. There's no point A to point B communication going here. Let's say that there's a huge pipe now, and this pipe is getting bifurcated here as well, here, and bunch of different servers are also trying to get this information. So all it needs to do is just listen to this pipe here. Just go and put a listener here. It just continuously listen for this information. The same information is what everybody is listening, but it's like saying that I want to get this information from this point to this point, which is going to take only 1 second. From A to B, it's going to take 2 seconds. It might take 1.5 seconds to reach here. It's just the different timelines that they are trying to get this information. So that's what you're talking about listening. I'm sitting here. There's about 4 or 5 people on the stream right now, and everybody is listening. I'm not talking to one person directly and sending information. Rather, I'm just giving out information and everybody is listening to it. And that's the only reason why they named it as listeners. And just going to be moving to the next part of this.
The next part of this is what are the two different type of listeners that are available in streams, and these two different type of listeners are for a specific purpose only. Hopefully I started the topic on the right note. So if you guys have any questions with streams itself, just drop it down right now, and I'll try to give a I'll try to answer your questions. Hopefully there are no more questions, so I'll just move on. mm, okay, looks like there's no questions. I'll just move on to the next topic, which is the two type of listeners. And two type of listeners, the first one is called as single subscription, and next is called as broadcast listeners. And as a developer, you should know what to listen for, and this is a very very important point. You should know what the type of the stream is going to be, and you should decide the type of the listener as well. So I'll tell what a single subscription is and what a broadcast listeners are. The single subscriptions are pretty much like a one-way direction paths only. So there's a path A right here. Oh, streams are unidirectional. Okay, so streams can be unidirectional, but in some certain cases, you can also send a stream back from A to B. You want to listen to a stream, and you can also create another pipeline and just send the stream back. But you cannot send the same data in the same pipeline that you listened for. So let's say this is the pipeline that you have. This information that is flowing from A to B, basically, right? And you can create another pipeline and send data from B to A, but you cannot send the data back again in the same pipeline. So a listener cannot act as a sender as well, but a listener can create another pipeline and create another separate listener and separate sender, and it can send information, but you cannot send the same information from B to A in the same pipe that listen to. When I say pipe, just think of it this way. That's why I would try to explain this. There's a file that is present here, like a text file, and this text file has probably 1,000 lines of data. This 1,000 lines of data in your computer is not saved as text information, right? It's saved as what? Any guesses what is saved in the most basic data that the computer saves data as? What is like the base of computation? Okay, I guess I'll answer this question myself. So the base of computation is binary. Binary information is what everything finally gets transcended to. You have like complex data that is present, it will finally flow as a binary information back to the computer. So a computer, which is the hard drive in your system, is saving a bunch of things in a binary fashion only. So what you want to do is convert this binary fashion into a text file. That's what you're trying to read. And when you're trying to open a text file, you open it in text pad, right? Notepad plus plus, some kind of a text file. And when you open that, the program that is responsible for that is continuously reading the binary information and is just sending to you. And that's what is basically the whole idea behind this binary information. So when I say continuously reading, what does it make it? It makes it as a pipeline, and it makes it as a stream of data. So binary information, it's not just 0 1 0 1 0 1 being finite or discrete information. It will flow as a pipe, and this 0 1 0 1 continuously keep on flowing here, and this pipe is what you're finally reading it as a text file. And this text file might have 1,000 lines of code, but in a binary fashion it might be like 1 million, 10 million, 20 million zeros and ones. So you cannot read everything in a single fashion, right? So you will never complete your text file. It just keep on loading one word by word, which we don't want. As soon as you open a text pad, you want to see all your 1,000 lines of 1,000 lines of text, which is possible because you are reading it in the form of a pipe. So you read everything in a pipe, and everything is read by the text pad or the notepad, and it's converting everything at once, and then it's showing to you. So that's the whole idea behind the pipeline. So this is what is going to be the concept behind unidirectional. So a pipe starts from A and finishes at B, and this pipe is just done. You once you use the pipe, and that's pretty much it. You cannot reuse it again unless you want to create another instance of the pipe. And you can have multiple instances of the pipe. Let's say that notepad plus plus is opening one text file. There is another text file, another program or application called as notepad plus plus, right? Notepad plus plus is also opening the same text file. Will the same text file open in multiple applications? question time. So my question is, there's a text file here, and there's a bunch of different applications: Notepad, Notepad plus plus, and you have Visual Studio Code reader, you have like a PyCharm reader, everything is there. But there's only one text file. So you are trying to open the same text file in bunch of different applications. Will it open or will it not open? Yeah, so it'll open, right? So what happens is that when you're trying to do that, you're pretty much creating your own pipeline. You're just creating a pipeline to read a text information, and this new application is doing it from everything. It's the same text is here, the same data is here, but different pipelines are created. So hopefully you understand that these pipelines are just unidirectional. At the same time, it's able to do things. At the same time, it's able to open multiple applications are able to open the same information. It's possible because it is attaching a pipeline. This pipeline is unique for that instance. This notepad is going to be the first application to open text. This notepad plus plus is going to be the second application to open the same text, but it is not sending the information through this pipeline, rather it is sending it to a new pipeline. That is what you can do. This is a very base example of the first type of listener as well, which is called as the single subscription listener. The single subscription listener says that once you open a file, that's pretty much it. You are opened a file and you've read all the information, and that's it. You can just close the file. That's all you can do in a single subscription. Just an open close kind of an action is possible through a single subscription listener. So these are all single subscription listeners. And once you read this text file, what else can you do? You can either edit it, you can do some changes in it, save it, and you close. That's pretty much it. You cannot do anything more than that. And there's no continuous stream of information coming here. There's only finite stream of information that is present in your hard drive and is reading via a pipeline, and once it is read completely, it is shutting it off. That's pretty much what is happening, right? And that is the first the listener, which is called a single subscription listener. So you can only subscribe once to this text file, and once the text file is pipeline is generated, it is generated, information is sent, and it's closed. That's all. The second type of subscription is called as the broadcast listener, which is basically for, think of it as a broadcast radio, right? A broadcast radio is present. You have 1,000 people present here, 1,000 people. There's only one person sending continuous stream of information for hours and hours. Probably, like say, he's sending the same information for 20 days, 30 days, and all these 1,000 people needn't have like one pipeline. So they might have a pipeline for a few seconds of time. They might have the pipeline for 1 minute, and this person might stop after 1 minute. So it's similar to what we are doing right now. I'm a person sitting here, I'm just talking to you guys, I'm just telling some information, and I'm just silent for next 5 seconds. So I'm just going to stay silent for 5 seconds, and that time you don't have to keep on listening. You can just think about, you look at something else, you can think about what is happening there, what is happening here, and after I talk again, you're again listening to it. That's pretty much what a broadcast listeners are also used for. The broadcast listeners are pretty much primarily used for a continuous stream of information that has a no start point, that has no end point, continuously coming into the picture. And if you want to listen to it, you focus your attention to it, you listen for it some time, and after some time it stops sending any information. So you're also pretty cool about it. You just leave it at that point of time, and you just do something else, and you come back to it when the broadcast starts again. So this is how the two different listeners are used for, and this is the two different information listeners that can catch a stream of information. So this is going to be a very huge stream. Pretty much think of it like a huge dam of water. This huge dam of water is going to continuously stay as a huge dam of water. There is nothing you can do about it. So if you want huge information that needs to be continuously streamed, you use a broadcast listeners, and the broadcast listeners can have n number of listeners attached to it. So 1,000 listeners, 20,000 listeners, 30,000 listeners, and is also one of the most important design patterns for any kind of application that you want to create. If you have any kind of an API that you're creating, if you're creating any kind of like a video based application, audio based application, all of these are going to be using a broadcast listeners left and right. And this is going to be for like an infinitely large stream, and this is going to be for a simple stream. The simple stream is basically going to be still an finite amount of data, but it's sending it in one single subscription. So just subscribe to it once only, get all the information, and then you close it and you just move on. So these are the two different type of listeners that are available in Dart, and we're going to be looking into creating the code in the tomorrow session, because in the tomorrow session I have a topic called as generators, and this is already actually scheduled. You can check it out. These generators are the base layers for streams. Generators, when you say talk about generators, it is like generating information every single time. So that's the topic, the brief explanation for a generator. So in tomorrow's session I'll give you guys like a full understanding of the coding part of this, because this is not very complex at this point of time. It's pretty simple. So that's what I'm going to be doing tomorrow. So just check for the next slide. Yeah, the code for simple stream, we can still do it, but I'll just talk about it in tomorrow's session. So one important thing that you need to know is, if you want to denote a future which is going to be an asynchronous future, which is going to be finite information, you just mark it with the word async, right? You just mark it with the word async. So there's a future you want to create. Futures are finite data. You mark it with the keyword async. The streams are infinite, meaning infinitely continuously flowing information, and continuous as well. And when you want to mark streams in Dart, you use the keyword async star. So async star means that it's going to be a stream. You just use the keyword async, it means it's going to be a future, and it's pretty much how you create your entire function after that. It's going to stick to the same kind of a function definition. You use it in only functions. Streams and futures can both be used only in a function. It cannot be used in a class. So that's what you're going to be finding out in tomorrow's session. So pretty much that's what I had planned as well. Let me check. Yeah, so I have about 5 minutes time, 4 minutes time, 5 minutes time. I'm open for questions right now. If you guys have any questions, you can let me know. Questions. Tomorrow's session is going to be also on the same time, 8 to 9 Indian Standard Time. So tomorrow's session will talk about generators and how these are very, very useful. And with the generators, we'll also touch a little bit about the streams as well, how to create generators. And as soon as you understand the concept of generators, you'll understand the concept of streams. Sync programming is what you're doing normally, right? You just have print statements one after another. That's pretty much the base of synchronous programming. So synchronous is when one after another, right? You have function A here, there's another function, you just invoking that function. So it's going to be taking that time to complete, and then you will go to that function, and that's how the synchronous program. So if you write a normal function without a synchronous keyword present anywhere, then it means that it's a synchronous program. So one after another will only get executed. There is no way that you can execute anything asynchronously. So let me give you a simple example. So let's remove this entire thing here from here. Yeah, and you want to just do like an await function, right? So just say await. Let's just say future dot delete. I want to say constitution seconds 3, and obviously you need a function, empty function. So just say empty function, print this is tone, right? And you're just doing some delay here, so it will not wait because you don't have an await. So you have a bunch of other print statements. Statement 1, statement 2. That's pretty much it. So if you use an await, I need to show guys how this entire thing works. So await cannot be without nothing. So all right, so let's run this application for now. Run this application. So this is what is going to happen. The first is going to get executed, right? First line is getting executed, waiting for 5 seconds, and it's going to do everything one after another. This is the base of synchronous programming. Everything that you normally write without the use of async Async is going to be base of the synchronous programming. Only after the first line is getting completed, only then the second line is going to go and get completed. There is no way that it will just jump from print statement 1, print statement 2 to this is the end. That is not going to happen unless you use the word asynchronous present. So if there is no function of asynchronous fashion that is getting called, then normally you write it in a synchronous fashion only. Any program that you take, not just this language, any language, by default will only write or work in a synchronous fashion. Everything is from top to bottom, starts from the point A and ends at point B. You should always have a starting point, always have an ending point, and that's the base of synchronous programming, and Dart is just doing it by default. If you want asynchronous, then that's what we are trying to learn here. All right, hopefully I did cover as much information as possible to you guys, and that's pretty much it from me. So I'm just gonna drop the stream right now. Hopefully you did learn a lot from the stream, and I'll see you guys in the next session tomorrow, which is the next session, and we'll see how it goes from here on. And probably next week we'll probably start with the Flutter again and discuss a little bit around Flutter. I also want to cover as much topics around design patterns and things like that as well. So a lot more people are getting engaged about it, and it's also the base for any kind of software development. So I'll see you guys. Cool. My voice is now clear. I don't know. I was still nearer to the mic only all the time. Anyway, so thanks again for taking your time to join this stream, guys. I'll see you guys in the next one. Until then, it's Bharat. Peace out. Have a super awesome day.